Video lecture on the discipline building materials. Educational program construction. Topic ceramic materials and art. Lecture plan. -1. General information. -2. Classification of ceramic materials and products. -3. Raw materials for the production of ceramic materials. -4. Clay additives. The purpose of the lecture. Introducing students to the classification of ceramic materials and products, gaining knowledge about raw materials for the production of ceramic materials and additives to clay. One. General information. Artificial stone materials and products obtained in the process of technological processing of mineral raw materials and subsequent firing at high temperatures are called ceramic. The name of ceramics comes from the Greek word keramos, clay. The material of which ceramic products are made after firing is called a ceramic shard in ceramic. Two. Classification of ceramic materials and products. By appointment, ceramic products are divided into the following types. Wall, finishing, roofing, fur floors, overlapping, road, sanitary, technical, acid resistant, heat insulating, refractory. By structure, ceramic products are distinguished with a porous and sintered, dense shard. Products with water absorption by weight of more than 5 are considered porous. These include products of both coarse, ceramic wall bricks and stone, products for roofing and ceilings, drainage pipes, and thin, facing tiles, paints, ceramics. Dense products include products with water absorption by weight less than 5. They also include products of both coarse, clinker bricks, large-size facing slabs, and fine, faience, semi-porcelain, porcelain, ceramics. According to the melting point, ceramic materials and products are divided into low melting, with a melting point below 1350 C. Refractory, with a melting point of 1350 C-1580 C. Fireproof, 1580 C-2000 C. Highest refractoriness, more than 2000 C. In terms of strength and frost resistance, ceramic products are divided into brands. According to the quality of processing of raw materials, ceramics are divided into coarse and fine. Rough. This is a building and fire clay brick, which is widely used in the construction of buildings and other construction work, facing tiles, pottery. Thin, porcelain, semi-porcelain, faience, majolica. By production and industry basis. -1. Architectural and construction, wall materials, bricks, wall stones, roofing materials, tiles, facade and facing materials, tiles, facing bricks, floor tiles, facing tiles for building interiors, sanitary ware, clinker bricks, sewer and drainage pipes, acid-resistant bricks. Two. Architectural and artistic, panels, inserts, reliefs, fireplaces, garden and park ceramics, large vases, sculpture, volumetric compositions, fountains. 3. Chemically resistant, the so-called stone Massachusetts bricks, tiles for lining chemical equipment and construction purposes. 4. Household. A. Household items made of faience and porcelain, various dishes, tea, dining, kitchen. B. Artistic and decorative items, vases, small sculptures, souvenirs. 5. Electrical, high voltage and low voltage insulators, porcelain fittings, etc. 6. Refractory, materials for furnace lining, capsule preparation, etc. 3. Raw materials for the production of ceramic materials. Various clay rocks are used as raw materials for the manufacture of ceramic materials. Glaze powder, the mineral mass is a plastic rock, capable of forming a plastic dough with water. After drying it retains its shape, and after firing it acquires the hardness of a stone. The main raw material for the production of building ceramic products is clay raw materials, used in pure form, and more often in a mixture with additives, lean, porous, fluids, plasticizers and other. Clay raw materials, clays and kaolins, are a product of weathering of igneous feldspar rocks containing impurities of other rocks. The composition of clays includes various oxides, Al, C, A, Ho, Na, HGO and KO, free and chemically bound water and organic impurities. The basic formula of clays is AlONCOMHO. In addition to clay minerals, clays include quartz, complicates forming, firing, lowers strength. Carbonates, increase porosity and shrinkage, reduce fire resistance, frost resistance, strength. Iron hydroxides, colored clay, reduce refractoriness and firing temperature. Organic impurities, burn out during firing, increasing the porosity and swelling of the shard. Clay mineral particles with a diameter of 0.005 mm less provide the ability, when mixed with water, to form a plastic dough that retains its shape when drying, and after firing it acquires water resistance and stone strength. In addition to clay particles, the raw material contains a certain content of dust particles with a grain size of 0.005, 0.16 mm and particles with a grain size of 0.162. Clay materials were formed as a result of the weathering of igneous feldspar rocks. The weathering process of rocks consists in mechanical destruction and chemical decomposition. Mechanical destruction occurs as a result of exposure to variable temperature and water. Chemical decomposition occurs, for example, when feldspar is exposed to water and carbon dioxide, resulting in the formation of the mineral colonite. The purest clays are composed primarily of colonite and are called kaolins. Colonite is a clay mineral from the group of hydrous aluminum silicates. Technological properties of clays. Moisture capacity is the ability to mix in a certain amount of water and retain it. Soaking, decay of large particles, accompanied by an increase in volume. Air shrinkage, when drying molded products, 4:15. Fire shrinkage during firing, 2:6. The particle size distribution of clays is the percentage of grains of various sizes in a clay rock. It is characterized by great variety. Particle sizes of fusible clays, microns, less than 5, 8, 65, 50, dust-like, 6, 55, 50, 250, sandy, 122. More than 1000, inclusions, -10. The increased content of particles with a size of less than 5 microns gives clays high plasticity and sensitivity to drying, increases shrinkage of products during firing. The increased content of the dusty fraction in clays increases the sensitivity to drying and firing, and reduces the strength of products. Clays containing coarse sand are less sensitive to drying than clays containing fine sand. When dried, the clay dough loses water and shrinks in volume. This process is called air shrinkage. The more clay particles in the clay raw material, the higher the plasticity and air shrinkage of the clay. Depending on this, clays are divided into highly plastic, medium plastic, moderately plastic, low plastic. Highly plastic clays contain up to 80–90 of clay particles. The number of plasticity is more than 25. Water demand is more than 28 and air shrinkage is 10–15. Medium and moderately plastic clays contain 30–60 clay particles. Plasticity number 15–25. Water demand 20–28 and air shrinkage 7–10. Low plastic clays contain from 5 to 30 clay particles. Water demand less than 20. Plasticity number 7–15 and air shrinkage 5–7. Non-plastic clays do not form plastic, moldable dough. Clay particles mostly consist of secondary minerals, colonite, montmorillonite, hydromica and their mixtures in various combinations. Clays with a predominant content of colonite have a light color, swell weakly when interacting with water, are characterized by refractoriness, have low plasticity and are not sensitive to drying. Clays containing montmorillonite are very plastic, swell strongly, sensitive to drying and firing, with the manifestation of curvature of products and cracking. The chemical composition of clays is expressed by the content and ratio of various oxides in ceramic raw materials. The content of the most important oxides varies within log limits: CO40, 80, AO8, 50, CO0, 15, Ta 0.5, 25, and Do 0, 4, or 3, 5. With an increase in the content of A, the plasticity and refractoriness of clays increase. And with an increase in the content of CO, the plasticity of clays decreases, the porosity increases, and the strength of fired products decreases. Four. Additives to clays. Lean additives. They are introduced into plastic clays to reduce shrinkage during drying and firing and to prevent deformations. Pore-forming additives. They are introduced to increase the porosity of the shard and improve the thermal insulation properties of ceramic dust. Float. They are introduced in order to reduce the firing temperature of ceramic products. plasticizing additives. They are introduced in order to increase the plasticity of raw mix. To improve the technological properties of clays, as well as to give the products certain and higher physical and mechanical properties. Quartz sand, comote, crushed refractory or refractory clay fired at a temperature of 1400 C, slag, sawdust, coal dust are added to the clays. The main types of ceramic bricks. They are distinguished by purpose and are subdivided into private, other names, construction or ordinary, and facial. The main types of ceramic bricks. They are distinguished by purpose and are subdivided into private, other names, construction or ordinary, and facial. Facial, depending on the technological design, can be of several types. Front, glazed, shaped, figured. Ceramic brick can be monolithic or hollow, and its spoon and butt surfaces are made smooth or corrugated. In this case, products of the same type often combine several features, so an ordinary block is made full-bodied or with cavities. The laying of stoves or fireplaces is made of special fire-resistant, fireclay bricks, and a special type of brick is used for paving paths, clinker. Test questions. -1. Rock-forming minerals, minerals of groups of silica, feldspars, ferruginous magnesian silicates, micas, clay minerals, carbonates, sulfates. They're distinctive features that determine the presence of certain properties in rocks. Two. Corrosion of natural stone and protection measures against it. List of references.
1. Алимов Л.А. Воронин. Строительные материалы. Учебник. М. Издательский центр Академия. 2012. 322. Мещеряков Ю.Г. Федоровс. Строительные материалы. Учебник. СПБ. Ноды под С и ПК. 2013. 400 Ил-3. Рыбьев И.А. Строительное материаловедение. Учебное пособие. Вторые АЦ. Исправу. М. Выш. К. 2014. 711.